Hi, this video is about UniConfig transactions. In UniConfig, we have two types of in-memory databases, or as they called in Open Daylight, data stores. One is config data store that displays the user intent or desired configuration. Second is operational data store that stores data as they are currently on the device. All of the config data store is mapped to operational data store, but operational data store can have additional so-called state data that cannot be configured and can only be viewed in operational data store. When we mount a device, both data stores are filled with identical device data. This process is called reconciliation. After UniConfig is synced with the device, we can start working with config data store. Changing data store data is described in the video working with Postman. Let's assume we already have some changes in config data store. Here is what we can do. The most common use case is when we want to execute on our config data store and push the intended configuration onto the device. But before we do the commit, we want to review change data. So here we have already one change that we've made in config data store. Let's verify that we cannot see that in operational data store. If you want to see the change data in a more uniform way, let's call an RPC called calculate diff. This RPC compares config and operational data stores. So after executing, we can see what data was created, updated, or deleted. To get even more accurate picture about our changes, right before we execute calculate diff, we execute an RPC called sync from network. This RPC updates our operational data store with the latest version of the configuration from the device. If we don't want to commit the changes we made, we can restore the config data store to match the operational data store using RPC replace config with oper. This RPC will copy the contents of operational data store into config data store, just like when we first mount the device, which means in our case, the non-operational data should match the config data. We can also save current config data store into a snapshot. A snapshot means a copy of config data store saved to a different type of topology, so-called snapshot topology. We can call create snapshot, delete snapshot, and replace config with snapshot RPCs. If we want to commit the changes, we are ready to call commit RPC. We have three types of commit in UniConfig. But first, let's get back to our change data. First commit that we have is called dry run commit. This operation doesn't actually send anything to the device, but as output, it returns a set of commands in case of CLI mount and yank data in case of netconf mount that would have been sent to the device if actual commit was executed. This operation is great when we deal with sensitive device and don't want to mess up with its configuration. Second type of commit is the actual commit that sends our intended configuration to the device. After the commit is successful, it updates the operational data store with changes made on the device. If the commit is not successful, rollback is performed. In rollback, all configuration already applied on the device within the same commit is rollbacked, which means opposite operation is called. Third commit is called checked commit. It is the same as commit, but this operation checks for configuration changes made on the device before applying actual commit. For further information about UniConfig transactions, go to docs Frinx.io.